Determine the equation of a line passing through the point -2, -7 and making an intercept of 3 units between two lines 4x plus 3y equals to 12 and 4x plus 3y equals to 3. Okay, let us begin. First, what we'll do, we'll try to understand the problem graphically. Let's consider two lines. One is the line L1 with the equation 4x plus 3y equals to 12. And then we consider another line L2. Now L2 is going to be parallel to the line L1. Its equation is going to be 4x plus 3y equals to 3. Fine. Next, what we'll do, we're going to consider a line that is going to pass through a point. Let's call it the point A, having the coordinates -2, -7. And that line is also going to intersect the two lines L1 and L2. So here we have the line, let's call it the line L, which passes through the point A with coordinates A -2, -7. It intersects the line L1, let's say at the point B, and the line L2 at the point C. We'll suppose that B has got the coordinates x1, y1, and C has got the coordinates x2, y2. Now, the intercept, the length of the intercept BC, it's given here that corresponds to 3 units. So using all of this information, our goal will be to determine the equation of this line L. Okay, so let us begin. So in the problem, it is given that L1 and L2 are two parallel lines. Now, the equation of the line that passes through the point A is going to be given by, we have the difference of the x coordinate, will take x minus -2 divided by cosine of the angle alpha. Now here, alpha is going to be the angle that the line L makes with the positive direction of x-axis. This is going to be equals to the difference of the y coordinate, so we'll take y minus -7 divided by sine of the angle alpha. Let's label this as equation number 3 and also specify what alpha is. So alpha is the angle made by the line L with the positive direction of the x-axis. Also, the points B and C are going to be 2 points on the line L. On the line L. This is actually the line L whose equation we have considered to be x plus 2 over cosine alpha equals to y plus 7 over sine alpha. Then we can say it such that they are at a distance of r and r plus 3 from the coordinate point A with coordinate value -2, -7. So what we'll do, we'll try to find out the coordinates of point B as well as the coordinates of point C. So here we have considered that B is, let's say, at a distance of r units from the point A, and C is at a distance of, since the distance between B and C is 3 units, so point C is going to be at a distance of r plus 3 units from the point A. Okay, so now what we can do, we can again apply the distance form to find out the coordinates of point B. Our goal will be to determine the coordinates of the point B. Okay, so here let's apply the distance form. The distance form tells us that we need to take the difference of the x coordinate. So we take -2 minus x1 divided by, we take cosine of the angle alpha. This is going to be equals to -7 minus y1 divided by sine of the angle alpha, and that is going to be equals to the distance between the 2 points A and B. So that is r. So that means here we have -2 minus x1 divided by cosine of angle alpha, that is going to be equals to r, and we have -7 minus y1 divided by sine of angle alpha, so that's equals to r as well. So x1 is going to be equals to -2 minus r cosine of alpha, and y1 is going to be equals to -7 minus r sine of angle alpha. So here we have successfully obtained the coordinates of the point B in a parametric form. So the parametric form is given by -2 minus r cosine of alpha, that is the x coordinate, and the y coordinate is -7 minus r sine of angle alpha. Okay, fine. Similarly, what we'll do, we'll try to find out the coordinates of the point C. So coordinates of point C, so that is going to be given by, so this time we have -2 minus x2 divided by cosine of angle alpha equals to negative 7 minus y2 divided by sine of angle alpha. So that is going to be equals to r plus 3. Okay, so we get negative 2 minus x2 over cosine of angle alpha, that is going to be equals to r plus 3, and we have negative 7 minus y2 over sine alpha, so that is going to be equals to r plus 3 as well. So let's find out x2. So x2, that is going to be equals to negative 2 minus, we have r plus 3 times cosine of angle alpha, and y2, that is going to be equals to negative 7 minus r plus 3 times sine of alpha. So we have obtained the coordinate of C as well. So let's note it down. The coordinate of C in the parametric form came out to be negative 2 minus r plus 3 times cosine of angle alpha. So this is going to be the x coordinate, and the y coordinate came out as negative 7 minus r plus 3 times sine of the angle alpha. Fine, we're going to use this fact in the next step. So here B is going to lie on the line L1. So that means the coordinate points of B must satisfy the equation of this line. So we should get 4 times x. Now in place of x, we're going to replace it with the x coordinate of point B. Negative 2 minus r cosine of angle alpha added to 3 times y. So what is y here? Negative 7 minus r times sine of angle alpha. This is going to be equals to 12. Okay, so let's simplify this. We're going to get negative 8 minus 4 times r times cosine of angle alpha minus 21 minus 3r times sine of angle alpha, that is equals to 12. So we are going to get 4r times cosine of angle alpha plus 3r times sine of angle alpha, that's going to be equals to negative 41. We're going to keep it aside for the time being. Let's give it an equation. We're going to label this as number 4. Next, what we have the point C passing through the point L2. So that means the coordinates of point C must also satisfy the equation of line L2. Now we need 4 times x. So x is going to be negative 2. We're using the x coordinate of point C minus r plus 3 times cosine of the angle alpha. This is going to get added to 3 times y. So y is negative 7 minus r plus 3 times sine of angle alpha. So this is going to be equals to 3. Okay, so we will simplify this. We get negative 8 minus 4 times r plus 3 times cosine of angle alpha added negative 21 minus 3 times r plus 3 times sine of alpha equals to 3. Then we have negative 8 minus 21, so that's going to be negative 29 minus 4r times cosine of angle alpha minus 12 cosine of angle alpha minus 3 times r sine alpha minus 9 sine alpha, that is going to be equals to 3. Okay, fine. So we now have negative 4r cosine of angle alpha minus 3r sine of angle alpha. Then we have negative 12 cosine of angle alpha minus 9 sine of angle alpha, that is going to be equals to, so we're going to transpose negative 29 to the right hand side combined with 3. That's going to give us 32. Okay, fine. So let's do one thing. Let's name this as number 5. We're going to add equation number 4 and equation number 5 together. So adding 4 and 5. So 4 added to 5. Negative 12 cosine of the angle alpha minus 9 sine of the angle alpha, and on the right hand side we have negative 9. Okay, so what we'll do, let's take 3 as the common factor, negative 3. So we have 4 times cosine of alpha plus 3 times sine of angle alpha. That's going to be equals to negative 3 multiplied to 3. Factoring out negative 3 from both sides, we are going to get 4 times cosine of angle alpha plus 3 times sine of angle alpha equals to 3. So let's try to simplify this. So what we'll do, we're going to keep 4 times cosine of alpha on the left hand side and then transpose the second term, which is 3 times sine alpha, to the right hand side. We get 3 minus 3 times sine alpha. So we'll square both sides to get 16 cosine squared alpha, and then on the right hand side we have 9 minus 18 sine alpha added to 9 sine squared alpha. So we can convert cosine squared alpha to sine squared alpha. So here we are going to take the help of the fact that since sine squared alpha plus cosine squared alpha equals to 1, so in place of cosine squared alpha we can also rewrite it as 1 minus sine squared alpha, which means that 16 times cosine squared alpha is simply going to become 16 minus 16 sine squared alpha equals to 9 minus 18 sine alpha added to 9 times sine squared alpha. So let's rearrange the terms. We're going to get 25 sine squared alpha minus 18 sine alpha, and then we have negative 7 equals to 0. Now this is going to be a quadratic equation in sine alpha. So when we simplify this, we are going to get the factored form as sine of alpha minus 1 multiplied to 25 sine alpha plus 7 equals to 0. So when we solve for it, we're going to get sine alpha equals to 1, or we could get sine alpha equals to negative 7 over 25. Okay, now that we have sine alpha, we can also need to find out its corresponding cosine alpha. So here cosine alpha, that is going to be equals to the square root of 1 minus sine squared alpha. We're going to consider the positive value. So whenever we have sine alpha equals to 1, its corresponding cosine value is going to be 0. So this is going to be one particular value. And then when we have sine alpha equals to negative 7 over 25, then the corresponding cosine alpha comes out to be positive 24 over 25. Okay, so now we are almost done. We will finally substitute this value into the equation that we took in the very beginning. So let's go to the first case. So this is the equation for the line L. We want to find out the equation of the line L. So we now have, so let's use the first case when sine of alpha equals to 1 and cosine of alpha equals to 0. In that case, our equation is going to be x plus 2 divided by, this is 0, divided by 0 equals to y plus 7 divided by 1. So when we cross multiply, so x plus 2 multiplied to 1 leaves us with x plus 2, and 0 times y plus 7, that's going to simply give us 0. So this is going to be the equation of the line when sine alpha equals to 1 and cosine alpha equals to 0. The other case is when we have sine of alpha equals to negative 7 over 25, the corresponding cosine alpha, which came out to be 24 over 25. In that case, what is the equation? So our equation becomes x plus 2 divided by cosine alpha, which is 24 over 25, that's going to be equals to y plus 7 divided by sine alpha, which is negative 7 over 25. So when we rearrange the terms, 7 simplified, we're going to get the final equation as 7x plus 24y added to 182, that's going to be equals to 0. So this is going to be the equation of the line. So we have two lines, equation of two lines. Thus, we can say, thus the equation of the two lines are equation of the line. So we're getting two lines, not a single line. There are two lines. Equation of the lines are going to be x plus 2 equals to 0, and the other equation will be 7x added to 24y plus 182. That is going to be equals to 0.